So in the previous part, we looked at the first couple of outlines of how to solve tree diagram problems. What I'm going to do now is I'm going to tackle a series of questions that will hopefully help you to address issues on this topic. So the first one. 6 out of every 10 cars in Britain are foreign made. First off, what is the probability that a car is British made? Well done for those of you who said 4/10, 0.4, 2/5 would also be okay as a simplified version, or 40%. Okay, next part. 2 cars approach. First off, find the probability that both are British, and then after that find the probability 1 British, 1 foreign. Okay, so first car, British or foreign? Car 1. Car 2, British or foreign? The probability a car is British is 0.4. So it's 0.6 that it's foreign. Multiply the probabilities to work out each branch. And list the event just to make it easier for yourself. So, both British is 0.16. 1 British, 1 foreign. Okay, that's here and here. So that's 0.48. So hopefully that question feels all right. We're going to continue and work through some more now. Any of these questions you want to do yourself, pause, look up the video, and then do as required. So, question number 2. So, there is an exam for a student. The probability of passing part 1 is 0.4. The probability of passing part 2 is 0.5. And the probability of passing part 3 is 0.7. Now, you get to attempt all 3 parts regardless. So first question for you. What is the probability of passing all 3? Now, because of where we're doing this, I'm going to draw a tree diagram now. Bear in mind there are 3 events. So it's part 1, part 2 and part 3. And what I'll do is I'll draw part 3 and part 2 first. And you'll see why because what happens is, drawing part 1, you see you have to go very wide, and if you get this wrong, these become more difficult. Pass and fail for everything, but you need to be careful here, because if you read the information again, the probabilities are different for each one. So here's the first one. There's the second. And there's the third. Now, passing all three, that's going to be the top option, which is PPP. This times this times this. Now, I'll do this stuff on a calculator at this stage. It's 0.14. Now, rather than working out all of the rest, I'm just going to stick to what I need at the moment and put that down. Okay, question B. What is the probability he passes 2? So, that's pass, pass, fail. Pass, fail, pass. And fail, pass, pass. Check the other ones by writing them down. Pass, fail, fail, so that's not helpful. I want this one, and this one for now. Fail, pass, fail. No use. 2 fails. Fail, fail, pass. And all 3 fails. So, multiply the pairs I need. And then combine those 3 results to get my probability. So it's 0.41. If he fails all 3 parts, he'll be thrown off the course. Well, that's 0.09 down there at the bottom. So, label the outcomes where they go, label the probabilities on the branches, check that your events are clear and separate, put your 3 sets of outcomes, calculate the branches you need for each option, and then add them up to get your answer for a particular part. Let's keep developing this now and look at a trickier question. And what we're now going to see is that actually we won't necessarily need to draw a tree diagram at all. Some of these we're going to do without. Here we go. So, here's a coin tossed twice. The probability of a heads on this coin is 2/3, making the coin biased. So I want to know the probability of getting 2 heads, and then I want to know the probability of a head and a tail from 2 throws. So now we're going to transition and see if we can do these without the diagram. What I want you to think about is, what branches along the tree would I need? And then perhaps, if necessary, sketch out some small part of a diagram. Now for the first one, 2 heads, that would be the branch that goes heads, heads. So I would take the probability of a heads and multiply it by the probability of a heads, which is 2/3 times 2/3. So I get 4/9. A head and a tail in 2 throws is one to watch out for. And if you remember, this could be a head then a tail, or a tail then a head. So a head then a tail would be 2/3, which is a head, multiplied by a tail, which is 1/3. Or represents add here, if you remember. And this will be tail, which is 1/3, times by the second branch, which is that. So this is a pair of branches, therefore we multiply, and this is the probability for each outcome. Now you might think 4/9 and 4/9 is a bit strange. The only other option is 2 tails, which is 1/3 times 1/3, which is 1/9. So 4, 4, and 1 makes 9, and that's the whole set. Okay, so hopefully now you're starting to get a feel for this, and perhaps you could even do some without requiring the use of the diagram. What we'll do is we'll pick up this in part 10 and do some more.